So what are we doing right now?
We are sifting through the rocks.
What did you find?
This looks like sapphire. Where's the black one?
No amethyst. One. Four.
What do you want our cups?
Four.
Those guys?
Four. None.
Just put them under. Can we just
That or just set them underneath one.
6. 1. None.
Name them what you have, Steph.
Okay. Iolite. 10. Smoky quartz. None.
We had clear quartz.
14. None. Garnet. 8. Kyanite. None. Sapphire. We have none. Moonstone. None.
Do you want us to do it in the same
Aventurine.
color or
None.
does it
And
matter?
Ruby. 1.
It doesn't matter.
But to me, it looks like it's in good condition. It doesn't stink.
Okay.
Still staying on 7.
It's still 7.
After the water test, that would tell us.
So what are you doing?
This is the collecting water.
For what?
I don't know.
Why is she collecting water?
He's going to run
She
more
doesn't know.
tests on it and tell us what mineral. He's going to run more tests on her water and tell us what things are actually in the water that we can't see. What abiotic factors.
What abiotic factors?
You want to do it to the side of you because look at the water how it's having to go around her. So you kind of put it to the side of you so you don't interfere. Because if you watch the water, you can see how it's going around both of you. It's not necessarily going between you. So put it to one side of her.
We're going on this side of it?
It doesn't matter. Okay. So she's going to set it down. I don't care who. Whenever they put it down, they're going to say go, and she'll start. And then you tell us whenever it gets to you and say stop. Okay. You ready?
Go.
Oh, look how cute he is. Oh, how sweet. It has to be even with your feet. Stop. Uh-oh. Barbara, pretend you need to get up. 8 seconds.
Yeah, 8 seconds.
So it went 10 feet and 8 seconds.
So your sample is in here, you're out of the creek, and we're going to put a chemical in it to, if there's phosphates, to turn green.
Okay.
So we're going to put that in.
All of it?
There should be a start over there.
Okay.
Oh, it is turning green.
Starch right here and the phosphates.
Cap it.
You can.
So you were always wanting pictures and helping elsewhere.
And we're looking for it to turn colors?
Not yet.
Okay. I was going to say it's not doing anything.
Now we have to add this one.
Oh, okay.
There's 2 chemicals that are added.
And what chemical is that?
Ammonium salicylate
Okay.
and ammonium cyanurate. So we dump that one in. And if there's any phosphorus, it'll turn green.
Okay, we're ready for our second chemical, I believe.
Which one are we doing?
Phosphate.
Oh, we're
Just did the first chemical.
okay.
It's kind of a yellow.
From the top with your water field.
Kind of like right with this one, wouldn't you say?
With the one that we added the chemicals to?
So,
Okay.
It's turning yellow.
And then we can put a lid on it.
Okay.
Shake it up good.
Okay.
And you're actually supposed to let it sit and develop. And the more phosphorus, the greener it'll turn. And there's numbers written on here. So it tells you the concentration.
Okay.
And then this one goes.
So what would you say that's at right now?
I would say 22.
22.
Oh, that's 2.
2.
Now the pH separates the...
Turn it so you can see it.
What are we looking for?
See these numbers right here?
Right.
Okay, we got to look at how yellow this is and see where it matches
okay.
on there and then look at the numbers.
Oh, I would
So
say
when
the
you
bottom.
It's right in here.
Yeah.
So it may right below the
yellow
2.
to green.
Right. It has to,
If there's
the longer
phosphate.
you let it sit longer and let it.
Yeah.
It's not all dissolved in there either.
Are you supposed to shake it? That's what I was wondering.
He had to shake it.
Oh, okay.
Okay.
Now is it? And you're supposed to actually let it sit 7.5 minutes.
Oh, okay.
We're not going to let it wait that long, probably.
Yeah,
And
but it's already.
yellow. Is it turning this one?
It's right here right now, but it looks like it could go that way. It's getting a little darker. It's been getting darker as we've been sitting here. Turn it that way. So
And so you try to match the colors as close as you can, and this is 0, and it goes up to 1 parts per million phosphorus. Some of
so
it,
like this would be what, 2?
0.2, 0.2.
Okay.
So it's about 0.2 maybe,
Okay.
but that's not real high. And this was ammonia. The ammonia probably could come from feedlots, the chicken places, fertilizers. You use ammonia in Windex.
Uh-huh.
All of those are sources of ammonia that the farmers that bring ammonia tanks out in their field and knife in ammonia. You know, all of that could potentially get into water. Here it's showing it's not real. And
3 or 4 minutes
with phosphates, you do something real similar. It's a color comparison. There's a little color wheel. And just your creek water goes in the side that's colored.
Okay.
And then your treated creek water goes on the other side. This is treated because it has a color indicator in it. And you let the sunlight, there's a mirror right here. So sunlight will reflect off of a mirror, and you turn this little wheel right here until the 2 colors are identical.
Oh, okay.
10, they had 10.
Is that like
Yeah.
right, yeah?
So that's 10 parts per million phosphorus. The phosphorus can come from fertilizers. We used to use a lot of detergents that had phosphate in it. And you probably buy detergents today that are phosphate free. So all of those were sources of phosphorus. to you and I, for the most part, the phosphorus, the nitrogen isn't going to do anything to us. They're nutrients. If you fertilize your garden, if you fertilize your yard, and you buy a bag of fertilizer, it has those 3 numbers on it, 20, 10, 5. That's the amount of phosphorus, nitrogen, and potassium that's in the fertilizer. So the phosphorus and nitrogen are actually nutrients for the plants. So if the water has lots of nutrients in it, you're going to get a lot of vegetation.
It should be this top.
And the vegetation could in turn take oxygen out of the water, and little by little it could kill a stream. So if there's a lot of phosphates in the water, then we might look upstream to see where it's coming from. Over-fertilization, it could be an industry just dumping into stream. And so here it's all pretty low. And I don't know what's around here, pastures, forests, you don't expect maybe lots in it. And so the oxygen level was really high, the phosphate was low, the nitrogen was low. When they dipped these nitrate strips in their water, it stayed colorless. And so there was 0 nitrates and nitrites in the water. So it's probably good water.